Welcome to the second part of Module 4 of Intuitive DevOps for You course. So, the second part of Module 4 is basically automate provisioning any cloud infrastructure with Terraform. So, here, the main focus will be put on automating the tasks such as provisioning any cloud infra with the Terraform. And this part consists of uh, the following things. It begins with the history of automation tools, and then we will expound and explore what is Terraform. Then we will look into Terraform workflow. Then we will understand and get to know the benefits and advantages of Terraform. Then we'll see some of the use cases of Terraform and Terraform configuration language, and what are the blocks and what it consists of, how does it look like. So that we'll see that Terraform configuration language. Then finally we will look into continuous deployment in this part of module 4. Then we'll do some hands-on exercises using Terraform and AWS cloud. So for now, let's begin with the history of automation. So Terraform is one of the most popular DevOps tool today, and also my personal favorite. So we will understand what is Terraform and how it works, and we are going to see several examples of doing provision with Terraform in hands-on experience. Sorry, in hands-on Terraform. So, but for now, let's first understand a little history of automation tools. So here the history of automation in the perspective of the tool popularity, not the tool in which year it's been released. So in which year the tool has taken storm in the market, in which year the tool has taken the maximum market share in the market. That's what I call it as a popularity. Based on this tool popularity perspective, I would like to understand, I would like to make you understand the history of automation. So, and this is how the automation world evolved and also got adopted into the DevOps movement. So, but before even the DevOps was so popular, what we used to use, do you know what we used to use? So it was bash scripting and then batch scripting. Of course, I was not there. I'm sorry, I was not there. I was not using at that moment, but still, I haven't had born. That's fine. Just kidding. Okay. And that was the time the operating system related automation, bash scripting was majorly used for Linux task automation, and batch, that's BATCH, batch scripting was for Windows. So bash scripting we have used in our module 2. So this is about welcome to the uh, multiverse, Linux multiverse, and there we have used for the bash scripting. So if you haven't gone through it, just go to the module 2 and part 2. So where there you can find the bash scripting. I have done a lot of examples. A lot means lot. So and then uh, and then we started getting other things like database automation, virtualization came in, and the cloud computing is getting started to evolve. So of course, so a normal Linux oriented operating system related tasks can be automated using bash scripting, and a Windows operating system related tasks can be automated using bash scripting. But when it comes to automating the tasks of database, virtualization, and cloud, it's pretty difficult. It doesn't have that capability at that time. So what we have to do, what can we do? Then came and then we started to look into new ways of finding and new ways of doing, new ways of working things. So there was a need of doing other kinds of automation also. So not just operating system tasks like virtualization tasks, and or cloud task, or any DB task, or any building automation. So programming language system admins or operations team started adopting programming languages like Python, Ruby, and even Perl. So if I say Perl, then Python and Ruby, but among all of these three, the Python got more popular because of its huge libraries, where we got library to automate various kinds of things. Even now, not that time, even now, many of the people, they ask for automation engineer. So the vacancies that they were posting, basically they're seeking Python only. So recently I think one of my friend got automation engineer role, and it's with 25 LPA. And what they have asked for Python only. So still, though there are a lot of tools have come into the market, but still the Python is, at least at a certain level, it is ruling, that I can say. Python is a ruler. So, so Python, anyway. But among all of these three, that's Python, Perl, Ruby, the Python got more popular. The biggest advantage of Python is huge, huge libraries, where we get library to automate various kinds of things. And also we have Perl, was also very popular, but Perl was being too much complicated. Its syntax is too complicated. So when you have to deal with a too complicated syntax, obviously it's uh, very difficult to sustain in a long run. So that's the reason Perl has taken a back step, whereas Python is leading even now. So I would say that these three, Python won the race in the automation. Along with the time, we got a PowerShell. So, but even Python stood for time testing. Anybody who wants to learn Python, I would always give a big thumbs up uh, for you to learn Python. So if you want to learn, you don't need to go anywhere else. Just same, go back to my YouTube channel, and there you will find intuitive Python for you course. I have made it very simple, damn simple. It's specifically focused on Python. It's you'll get in-depth understanding about Python, with the fundamentals as well as in-depth concept. So you just go and explore the Python course. That's also very good. So then, as um, uh, along with the time, we got PowerShell also, which was, of course, which is only for Windows specific. So, but from Windows you can automate other things like VMware related automation. And then after that, the time came for configuration management tool. That's where the configuration, after all these things, it's a step by step evolution process. Then after that, there came a configuration management tools generation has been started. So the first one that entered is Puppet. So Puppet came in the world came in the world, the Puppet came in, and once the Puppet has come, and then the word configuration management came into use. So basically, the Puppet is the one who brought the word configuration management. So Puppet was not initially considered as an automation tool. So it was more of managing configuration. The perspective of it was, let's say you have many servers, you have cluster of servers, a cluster of web servers. So let's take example, and from the cluster of web server you have a configuration. So almost all the web servers in a cluster will be exactly similar. So the configuration will be similar, their package, their service status will be similar, but sometimes we used to make changes to those servers, and they used to go out of sync, the synchronization. So some configuration file we made some changes, or service state has gone down, so service has stopped. Any kind of configuration related change was supposed to be managed through a centralized server. So a Puppet server, on Puppet server will have the configuration of all of your servers, and mm, and Puppet server is going to apply like a law, and all the missions where we want to manage the configuration will have an agent that will regularly query to the Puppet server about its configuration, and everything used to be in the right state. So configuration state across your infrastructure was supposed to be managed through a Puppet server. But then when the DevOps movement came in, we started adopting Puppet as an automation tool. Along with Puppet, we had a Salt Stack, which was very nice and simple tool to execute commands on a remote machine. So a combination of Puppet and Salt Stack was very famous. Generally, we used to run Puppet agents through Salt Stack, an initial setup through Salt Stack, and then most of the configuration through Puppet. So it was the kind of mixture or combination of using multiple automation tools, and after that came Chef. So now Puppet, especially configuration management tool, and there was no programming language over there. So Puppet is built on Ruby. If you get back to 2006, again here Perl, Python, Perl, Ruby, and Puppet was built on Ruby. So Salt Stack on Python again. So Python is master. So but we do not need to write the Python code or the Ruby code, in that it has its own language. So Puppet has its own language, domain specific language, the DSL. So now came Chef. So now the Chef came with more manageability and more power to the user. I suppose that's what I personally felt. So we had the power of writing Ruby code also through Chef, and there are more templating and more features. So the graphical user interface was there, so which was very good. It's still there, so you can generate reports and stuff like that. So but along with all these features, it came with more complications. There are too many moving parts in Chef. So you have server, you have the client, and you have the workstation. This is too many to handle. Okay, So now I'm not saying that either Puppet or so Puppet is good, Chef is bad, or Chef is good, Puppet are bad. No, nothing like that. It's all just a matter of the use case or your inclination towards a tool that also matters among all this. So now we have programming, we are scripting, then then we have the programming languages that are used to create one new application such as Puppet and SaltStack, and then Chef as a configuration tool. So we have a lot of options at this moment when you compare at the 1989 or at that moment. So and then came Ansible, so which was again a configuration management tool developed by Michael Dohan. So Ansible was written in Python. Again, the Python has come into the picture. And out of all this, Ansible is the most simplest automation tool. It was acquired by Red Hat then, and now you have a lot of things in Ansible. You have Ansible Tower and you have enterprise versions. So Ansible came with an idea of simplicity, having a very simple code to manage your huge infrastructure. Of course, the Python itself is a simple, and the Python itself has come with the simplicity. Of course, whatever you make through with the Python would be much simpler. So that's what had happened with our Ansible also. So Ansible initially came in more focused on Linux machines only. So then the Windows automation was also possible through Ansible. It's still possible through Ansible. So, and then cloud automation, the networking tool automation, database automation. There is so much of integration came in the Ansible now. So it's continuously evolving process. They're adding so much of functionality, so much of integration to the Ansible year by year. So being simple, it also become very popular automation tool. So Ansible is the at this moment the powerful tool for automation, and it can handle all types of automation, from cloud, networking tool, database, Linux, and Windows, almost all, everything, and that too it's simple. So that's the reason it's a favorite. So, and also we have Terraform and Cloud Formation, which are all uh, cloud, mostly cloud automation tools. Basically, Terraform is a cloud automation tool. It's specifically meant for the cloud automation tool. So now Ansible, you can do automation, cloud automation with Ansible, but Terraform is more cloud specific automation tool, and sure, Terraform also supports some other kinds of automation, but specialization is in cloud automation. So this is a little history. This is a little history from tool popularity year perspective of how automation has evolved from bash and batch scripting. So today, to you having Ansible and Terraform. So don't think it will stop here. It will go on and go on, go on, and it will go on forever. So maybe after 3 to 4 years, we do not know what uh, tool will come and take a storm, and what tool will come and take the complete market share. Who knows? So they're sure there are more automation tool, but talking about the most popular one and famous being in their own specific areas. So, and we are going to learn Terraform in the forthcoming slides. Um, just to refresh, in the previous module in uh, DevOps and IAC, in that we introduced the tools practices and the benefits of infrastructure as code and its impact on DevOps culture. So, out of all of the IAC tools, that infrastructure as code tools that have been mentioned, so one that is particularly powerful when it is look at the tool in perspective with respect to cloud is Terraform. Obviously, Terraform. So which is part of the Hershey group, Hershey Corp tool suite. So that's what from there so whatever that you see on the screen, so most of the information that I gathered from their documentation, Hershey Corp documentation, they have a nice documentation. So now the question arises, what is Terraform? Terraform is an infrastructure as code IAC tool that lets you one build, two change, and three version cloud and also on-premise resources safely and efficiently. So as I was repeating like a broken tape record for almost 10 to 15 times in this module itself. So Terraform is widely used for cloud, but it doesn't mean it's not useful for on-premise resources. It can be used for the on-premise resources also, but it is mainly it's made for cloud, but it can be used for the on-premise resources also. So but what are the activities that you do using Terraform? It lets you build, change, and version cloud and on-premise resources safely and efficiently. So HashiCorp Terraform is an infrastructure code infrastructure as code that IAC tool that basically lets you define both cloud and on-premise resources in human readable configuration files. So here you will have a Terraform configuration file that's basically human readable format only. So that we are going to look into that file in our forthcoming slides. So there you are going to mention about how you want to provision your server in cloud or else in on-premise. So basically this human readable configuration files, there using that you can version, you can reuse, and you can share. So that's the benefit of these configuration files. You can you can use then use a consistent workflow to provision and manage all of your infrastructure through its life cycle. And Terraform can manage low level components like compute, storage, and networking resources also, as well as a high level components like DNS entries, that's domain naming system entries, and SaaS features, software as a service features. So now let's look into the flow of a Terraform. How does Terraform work? So Terraform creates and manages resources on cloud platform. You can see on the window the animation. Terraform creates and manages resources on cloud platform and other services through the application programming interface, that's called API in short. So that's what. So basically Terraform creates and manages resources. Basically a resource can be a instance or VM or could be anything. So that resources you can create or you can also manage on cloud platforms, particularly cloud platforms and other services. You can have other services also, but particularly on cloud platform through the API. Through API. So here you will have a Terraform, then you will have a configuration file, then through API it will connect to the cloud of cloud platform. Then you can either create a new virtual machine, new instance, or you can manage that. You can do changes, you can stop it, you can restart it, you can do a lot of activities with one configuration file, and that configuration file can be shared, reused, and yeah, shared, reused, and you can do modifications and you can version it also. um, so uh, providers enable Terraform to work with virtually any platform or service with an accessible API. Now let's look into Terraform workflow. So HashiCorp and the Terraform community have already written thousands of providers to manage many different types of resources and services. You can find all publicly available providers on Terraform registry, including Amazon Web Services, Azure Cloud, Cloud Platform, Kubernetes, Helm, GitHub, Splunk, Datadog, and many more, many more, many more. So let me take you through that. Terraform, okay, here it is. And then Terraform registry. Yeah, the correct one. Here we can find out the providers. So browse providers, browse modules, browse policy libraries, browse run tasks. So let me click on, yeah, here you can see featured providers, but if you click on browse providers, you'll get it. So these are the providers are logical abstraction of an upstream API. They are responsible for understanding API interactions and exposing resources. Okay, so our Google platform, Azure, Kubernetes, Alibaba Cloud, Oracle Cloud Infrastructure, AWS, Amazon Web Services, then Active Directory, Archive, AWS Cloud Control, DNS, CloudInit, External Workspace, Helm, Nomad, HTTP. So a lot of providers are, partner providers are these. So now let me get back to the previous slide. Here you see this, that's the reason that time I did not stress this uh, flow chart up, because so once I show the providers, actually then I can if I explain it would look much better. So here what happens, you have a Terraform and then Terraform provider, Terraform provider, and then target API. So you got to know, you know Terraform the tool, and then you know who are the Terraform providers, then you know what is API. So API. So this is how the whole Terraform system works. So then, so let's get back. So as we have discussed, there are n number of Terraform providers we have. So such as AWS, GCP, Kubernetes, Helm. So now the core Terraform workflow consists of three stages that you can see on your screen: write stage, plan stage, and apply stage. So what happens in a write stage? In a write stage, you define resources which may be across multiple cloud providers and services. For example, you might create a configuration to deploy an application on virtual machines in a virtual private cloud network with security groups and load balancer. It's a lot. So all these things you can do with one configuration file. That's what I'm saying. Your deployment, it's basically a huge manual process. A deployment, basically what example I have taken here, the example that I have taken is, so to deploy an application in virtual machine, of course, and after that in a virtual private cloud. So VPC, virtual machine, and an application. For that, you obviously have to set up your security group and then load balancer. So in cloud, how many services are required to do this exercise? You need a virtual machine, you need a VPC, you need a security group, you need a load balancer. Security group you can create when you set up an instance, that's fine. But by and large, you require a 4 services. So it took a lot of manual work to do. But what you can do is to deploy an application in a virtual machine, in a VPC with a specific security group, using a load balancer. So it's all, you can run it, you can write a file. You have to define the configuration file, and then there are two types again: Terraform configuration and then Terraform state files. So now we are not talking about the state file, now we are talking about the Terraform configuration file. So in that configuration file you mention all these activities, then automatically if you apply that configuration file, your activity will be done and you see the application running and you can access the application. Got my point. So that's what the write is. So write define infrastructure configuration files. So the second stage for us is plan. So plan. Terraform creates an execution plan describing the infrastructure it will create, update, or destroy based on the existing infrastructure and your configuration that you have written. So it all depends upon your configuration file, but it will create a plan how to do, how to execute the execute the orders that you have given in configuration file. That's what happens in plan. In plan, it review the changes Terraform will make to your infrastructure. That's what the plan is. Then we have the most important and then final stage of Terraform workflow is apply. So apply on approval. Once it is given approval, Terraform performs the proposed operations in the correct order, respecting any resource dependencies. For example, if you update the properties of a VPC, that's a virtual private cloud, and change the number of virtual machines in that VPC, so will create Terraform will recreate the virtual private cloud, scaling the virtual machines. So this is one example for the apply. You can take a lot of examples. However, so here, so this workflow, creating a configuration file, then plan the changes, then apply it to the specific service provider. It could be AWS, Datadog, GCP, and Microsoft Azure, or you have 1,000+ providers. And this is the workflow of Terraform. So as we have seen the Terraform workflow, so now let's look into the advantages of Terraform. So one of the most big advantage of Terraform is it can manage any infrastructure. So find if you want to find providers for, so many of the platforms and services you already use in the Terraform registry, so you can go there and you can check Terraform registry. So then there you can find almost all of the providers, and you can also write your own if you want. So Terraform takes an immutable approach to infrastructure, reducing the complexity of upgrading or modifying your services and infrastructure. And to track your infrastructure, Terraform generates a plan and prompts you for your approval before modifying your infrastructure. It also keeps track of your real infrastructure in a state file, which acts as a of truth source of truth for your environment. So Terraform uses the state file. state file and configuration files too are there. So Terraform specifically uses the state file to determine the changes to make to your infrastructure so that it will match your configuration. And the third advantage of Terraform is automate changes. Terraform configuration files are declarative, meaning what does the declarative meaning? So the declarative mean that they describe the end state of your infrastructure. You do not need to write step by step instructions to create resources because Terraform handles the underlying logic. So Terraform builds a resource graph to determine a resource dependencies and creates or modifies non-dependent resources in parallel. So this allows Terraform to provision resources efficiently and effectively. Then the fourth one is standardized configurations. So Terraform supports reusable configuration components called modules that define configurable collections of infrastructure, saving time and encouraging best practices. You can use publicly available modules from the Terraform registry or write of your own. And collaborate is one more benefit, is it's a best for collaboration, a collaboration tool. So since your configuration is written in a file, you can commit it to a version control system, VCS, and use Terraform Cloud to efficiently manage Terraform workflows across teams. So Terraform Cloud runs Terraform in a consistent, reliable environment and provides secure access to shared state and secret data. So role-based access controls a private registry for sharing both modules and providers and more and more. So now let's look into some of the use cases of Terraform. So HashiCorp Terraform is an infrastructure as code tool, that's a IAC tool that lets you define infrastructure resources in human readable configuration files that you can version, reuse, and share. So you can then use a consistent workflow to safely and efficiently provision and manage your infrastructure throughout its life cycle. So this slide describes popular Terraform use cases and provides related resources that you can use to create Terraform configurations and workflows. We will begin with the most important and widely helpful use case is multi-cloud deployment. So in multi-cloud deployment, provisioning infrastructure across multiple clouds basically increases fault tolerance, allowing for more graceful recovery from cloud provider outages. However, multi-cloud deployment is not that easy. It's very complex. So multi-cloud deployment add complexity because each provider has its own interfaces, own tools and own workflows. GCP, their own interface. If you see the Google Cloud Platform, their interface is different. Amazon Web Services, their interface is different, and IBM is different, and Azure is different. I have worked on by and large all of the cloud platforms that I have just mentioned. Each of their interface is different, tools are different, and workflows are different. However, fundamentally the services they provide are same, but the names of the services changes and with a slight complexity attached to that. So Terraform lets you use the same workflow to manage multiple providers and handle cross cloud dependencies. So this actually simplifies management and orchestration for large scale multi cloud infrastructures. And the second use case using Terraform is application infrastructure deployment, scaling, and monitoring tools. You can use Terraform to efficiently deploy, release, scale, and monitor infrastructure for multi-tier applications. So, if you see you require for any microservices or any big application, if it is a microservices application, it consists of lot of microservices, and if you want to run it separately in instances, then you have to deploy, release, and monitor a lot of infrastructure, a lot of instances. In that case, this one our Terraform would be come to our rescue. So entire application architecture lets you scale application components independently and provides a separation of concerns. An application cloud consists of a pool of web servers that use a database tier with additional tiers for API servers, caching servers, and routing meshes. So Terraform allows you to manage the resources in each tier together and automatically handles dependencies between tiers. Let's take one example to get the clear picture of what I'm talking about. Uh, for example, Terraform will deploy a database tier before provisioning the web servers that depend on it. So this is the best example to reflect what I was talking thus far. Then we have the third use case is PaaS application setup. Platform as a service. Basically, PaaS is platform as a service. So this is the best use case for the for using Terraform. So setting up a PaaS, a platform as a service. So PaaS vendors like Heroku, of course, Heroku allows you to create web applications and attach add-ons such as databases or email providers. So Heroku can elastically scale the number of dynos or workers, but most non-trivial applications need many add-ons and external services. So in this case, in this kind of complex situations, you can use Terraform to codify the setup required for a Heroku application, configure a DN, simple to set a CNAME, and set up a Cloudflare as a content delivery network for the app. CDN, a content delivery network for the app. So Terraform can quickly and consistently do all of this without a web interface. And the best and the fourth use case is Kubernetes. Kubernetes, as we all know, it's an open source orchestration, container orchestration tool in specific. So Kubernetes is a open source workload scheduler for containerized applications. So Terraform lets you both deploy a Kubernetes cluster and manage its resources. What are the resources of Kubernetes? If anybody knows, just repeat with me. It's one is pods and deployments and services. So for each of thing, you have to write a definition file, the Kubernetes definition file to create and manage these resources in the Kubernetes cluster, such as pods, deployments, and services. So Terraform makes it much simpler because I have worked on Kubernetes without Terraform and Kubernetes with Terraform. With Terraform, it's a cakewalk. It's simply a cakewalk. So you can also use the Kubernetes operator for Terraform to manage cloud and on-premise infrastructure through a Kubernetes custom resource definition, CRD, custom resource definition file, and Terraform cloud. Then the last but not least use case is software demos. So you can use Terraform to create provision. You can use Terraform to create provision and bootstrap a demo on various cloud providers. This lets end users easily try the software on their own infrastructure and even enables them to adjust parameters like cluster size to more rigorously test tools at any scale. So then we'll close up, we'll wrap up the use cases with one more. So in software demos, there is a concept called parallel environments. You may have a staging. That's what in software demos, basically we'll have a lot of deployment stages. So one in production, then development, then you will have a staging area, then testing area. So there are different stages where we deploy our application. So that's why parallel environments, you may have staging or QA, that's quality assurance environments, that you use to test new applications before releasing them in production. So as the production environment grows larger and more complex, it can be increasingly difficult to maintain an up-to-date environment for each stage of the development process. So Terraform, what does Terraform do? How will Terraform help us? Terraform lets you rapidly spin up and decommission infrastructure for development, test, QA, and production. Using Terraform to create disposable environments as needed is more cost efficient than managing each one independently. So, in a nutshell, if you put it in a single in a one two lines of statement, so Terraform will help you from development stage till production stage in setting up the servers and configure in setting up the servers with rapidly. Okay, so that's how it helps. So it's this Terraform, using Terraform to create disposable environments as needed is more cost efficient than maintaining each one independently. We have seen the basics of Terraform, workflow of Terraform, and then use cases, benefits of Terraform. So now let's look into the Terraform language, Terraform configuration file, Terraform state file. Okay, so Terraform language. So use the Terraform configuration language to describe the infrastructure that Terraform manages. So the main purpose of the Terraform language is declaring resources. I'm repeating again one more time. The main purpose of Terraform language is declaring resources which represent infrastructure objects. All other language features exist only to make the definition of resources more flexible and convenient. A Terraform configuration is a complete document in the Terraform language that tells Terraform how to manage a given collection of infrastructure. A configuration can consist of multiple files and directories. And the syntax of the Terraform language consists of only a few basic elements, not too many, not too complex, only three basic elements. So you can see on the screen on left side an image with three basic elements. It begins with a block type, and then arguments, and then expression. That's it. See here, forget about the first block. Here the name block type, and then block label, and then another block label, and then here the block opens example, the same example which is written on top as a Terraform configuration language. So I'm explaining here. So it consists of only three fundamental elements. Those are, first one is a block type, second one and third one are block label, then your curly braces opens up, the block opens, and then inside you, this is your block body. Whatever you write inside, that is your block body. So there you will have again an identifier equal to an expression. So this is called an argument. The whole thing, you write a number of arguments, argument 1, argument 2, argument 3, and this argument consists of an identifier. It's like a variable name, and then it's equal to an expression, and then your block will be closed. Here if you take this example, resource is your block type, and then block label AWS virtual private cloud AWS VPC is a label, and then what type, it's a main label, and then the block is opened, and then inside you have an argument inside the block body, that is identifier is CIDR block, and then this is your expression, and then block is closed. So blocks are containers. You can see this block is like a container and for other content, and usually represent the configuration of some kind of object like a resource. So blocks have a block type. It begins with a block type, can have 0 or more labels. Sometimes you don't need to put even a single label, but you can have 0 or more label, n number of labels, and have a body. This is your block body that contains any number of arguments and nested blocks. You can have a nested block, a block inside a block inside a block inside a block, a nested block. So most of the Terraform features are controlled by the top level blocks in a configuration file. So this is your top level block. If there is one more block inside this block, a top level block, that's a nested block. So most of the Terraform features are controlled by the top level blocks in configuration file. Then we have argument. So argument basically assigns a value to a name. So this is our value and this is our name. So that's why we call it as identifier. The name is like variable identifier, and then expression is our value. So they appear within the blocks. And then expression. So expression represents a value. Expression is nothing but a value, and either literally or by referencing and combining other values. So they appear as values for arguments or within other expressions. So let's read through a complete piece of Terraform declarative language. So the Terraform language is a declarative, describing an intended goal rather than steps to reach the goal. So the ordering of blocks and the files they are organized into are generally not significant. So Terraform only considers implicit and explicit relationships between resources when determining an order of operations. Let's take this example which is on your screen. So the following example describes a simple network topology for Amazon Web Services. Just to give a sense of the overall structure of the structure and syntax of the Terraform language, similar to configurations can be created for other virtual network services using the resource types defined by the other providers, and a practical network configuration will often contain additional elements not shown here. So if you look into this example, so you can see various blocks, and then this is your Terraform block, and after that it's a block type, it's a variable type, and then this is AWS region is your block label. Then we have where another block type, this is completely empty, that variable block type is put empty. Then another variable with base CIDR block, this is your block label. Then you have two arguments inside that, one is default identifier and 10.1.0.0 and /16. If you remember CIDR, IP4 IP version 4, and then CIDR is a subnetting or subnet mask. And then so we have discussed this in networking layers. If you haven't watched that, go back to the networking module and then watch this and get the complete understanding, and then come back, because you should not have any confusion of any kind of topic in DevOps and MLOps. That's the reason I'm telling. So there it's a description. In description we have mentioned /16 is CIDR range definition such as 10.1.0.0 /16 that the VPC will use. So here if I would like to explain, so what this mean is, as it is 16 means 8 plus 8 once. So the first octet and the second octet defines the network, and then last two octets, the 0.0, this third and fourth octet represents the host. That's what this says. Then we have the another block, that is variable block again, but this time it's availability zones. Here the two arguments basically talk about availability zones. So then the provider block, this is very important. The provider block, who is the provider for us now? AWS, Amazon Web Services. And then argument is region. Here where dot Amazon Web Services region, where you want to launch your instance. Then you have resource type block, AWS VPC, and then main. These are the two again argument, so sorry, block labels. And then one more resource block type, that is AWS subnet type. Here we have to mention about the AWS subnet and then availability zone. And VPC ID, here which VPC in which virtual private cloud you want your instance, and that information you have to provide here. Then here finally CADR block again. So we are going to do this practical demonstration using Amazon Web Services only. There is no point of worry. So we will look into this in hands-on Terraform.